Hello friends, in this session we will discuss about process scheduling and the various stages of a process. So we'll also discuss the process life cycle, which comprises of the various states a process visits during its entire life cycle. So let's start with it. Scheduling we've already discussed earlier, so I'll just briefly touch upon it. So the scheduling, if we discuss the generalized notion of the scheduling word is the task of finding the perfect mapping. And by this perfect mapping, what do we mean is, when I say this perfect mapping, it actually means that we try to maximize some particular criteria, and that criteria, whenever it gets maximized or we reach a particular trade-off on the basis of it, at that point we say that it is a perfect mapping. So in case of process scheduling, we say that we try to find a perfect mapping between a set of processes and a set of available resources. So we try to assign our processes in the best manner to our resources in such a manner that the resource utilization is also maximum, and the other criteria like maximum throughput, minimum response time, minimum turnaround time, etc. are also fulfilled. So that entire thing is discussed in our previous process scheduling algorithms video. You can please look upon it for your reference. And next we'll be particularly focusing in this particular language, we'll be focusing upon the life cycle of a process. So if I move on, I would say that there are different phases of scheduling in which a particular process or a set of processes are scheduled to our resource, which is CPU, the main resource in case of a computer system, in case of a computer science term. When we say processes, the main resource that processes need is the CPU. So the CPU should be utilized to the maximum extent. And when we discuss upon process scheduling, we say the best manner in which the CPU is assigned to various processes and the CPU is used is known as your process scheduling, and it is the main motive particularly. So there come various phases of scheduling. And what are those phases? So we have three phases. Whenever we discuss the concept of scheduling, and that too in computer science, when scheduling processes to CPU, we have three processes. The three processes are long-term scheduling, mid-term scheduling, and short-term scheduling. So the three phases are these. And the long-term scheduling is handled by a job scheduler or the long-term scheduler. Mid-term scheduling is handled by mid-term scheduler or a swapper. Short-term scheduling is handled by short-term scheduler or your dispatcher. Right. So I'll just briefly discuss their meaning first, and then we'll move on to the details of various states and how these three schedulers work in between the various states. Right. So long-term scheduler, we discussed long-term scheduler. So it is basically used for selecting the jobs to be executed. So for your from your entire set of processes, if you first of all, the work first starts with this long-term scheduler. It selects a subset of jobs to be executed onto your and to be sent to your CPU. So basically it just selects a subset of processes and sends it into your ready queue. So its main task is selecting the jobs to be executed. It selects a certain set of jobs and inserts into the ready queue. That's it. That's all is its task. So main task is to select the processes or jobs to be executed and populate the ready queue with it. Then comes a midterm scheduler. Now midterm scheduler, basically its task is to swap in and swap out the processes in need of some input-output operation. Now for example, I was performing some task and now I need to perform some input-output task. The input-output task could be like, for example, for my process to work execute a particular command, I first of all need a particular user input. So I'll have to wait for the user to enter that input, right? So that input from the user is basically known your input output task. Or another example of an input output task could be when you're waiting, let's say, for a resource to serve your command. For example, I'm waiting for printer to serve my printing command, and then my next program instruction would execute. So that is known as input output task. So it is always advisable that you just preempt your process in order to completion for that input output task, and then you continue its execution, so that for that amount of time when it is executing its input output task, some other process can utilize the CPU. So that's all is the purpose in that case, right? So next we move on to your short-term scheduler. So short-term scheduler is also known as the dispatcher. And what is its role? So it basically deals with, short-term scheduler deals with assigning the processes to the CPU. So it is the main scheduler which is actually interacting with your CPU. So what does it do? It just takes the task in the ready queue and decides which process should move on first to the CPU and which process should actually be assigned the CPU. Right, so selecting processes from the ready queue to be assigned to the CPU, and the main task is to handle the execution of a process, that is assigning the CPU to the processes, making the decision as to which processes in the ready queue should be assigned the CPU, and shift it to the ready queue again if any interrupt arises. Now that's all is the role of the three schedulers. Now we move to the main diagram, which is the diagram which represents the various states of a process, representing the comprising the life cycle of a process. So this is the entire diagram. It took me a while constructing this diagram. It is as per my knowledge, it is not available in any of the textbooks, so I've just used the knowledge of various textbooks to construct this. So let's discuss this. So first of all, whenever we say that we have a certain set of processes, whenever a process is created, it is said to enter this new state. Fine. So when I create a process for the first time, it is said to enter this new state. Then the long-term scheduler, as we discussed just now, it chooses various processes from this. So it chooses a various we would say a subset of processes from here and inserts them into this ready queue. So whenever I say it inserts it into the ready queue, the process enters the ready state. Fine. So from new state to ready state, the long-term scheduler makes a call that which process should be sent to the ready queue and which should not. Fine. Basically, the main motive over here is that there should be a certain set of threshold processes available in your ready queue, so that your CPU is never waiting is never idle in order to see that are there any jobs available in the ready queue or not. And if I say there are a lot of processes available over here in the ready queue, then the short-term scheduler will be just busy in deciding upon. So there will be a lot of time wasted in deciding upon which process should be sent over here in the running state. So that therefore they just put a subset of processes over here. So that is the main motive of long-term scheduler, to let's say shorten some task of this short-term scheduler, and also help the CPU to avoid the waiting time for that could be incurred while waiting for the available processes that should be executed on CPU, right? So next is the ready state. From the ready state, the processes enter the running state when the short-term scheduler makes a call as in which process should be assigned the CPU the next. Fine. So if any software interrupt occurs, if any problem occurs, then the short-term scheduler only preempts the resource and moves it into the ready queue. So this entire part is handled by the short-term scheduler. Now let's say in case the process that was running has now issued some input output demand, then it is preempted and it is sent to this blocked or waiting state. Now this is also done by your short-term scheduler. Just hold on to this, don't mix it with mid-term scheduler. It comes over here, we'll discuss that. But whenever a process is executing, say I also discussed in the beginning, the entire task of execution of a process is handled by your short-term scheduler. Fine. So whenever it issues an input output demand, it is shifted to this blocked or waiting state, and on the completion of input output demand or input output task, it is again shifted to this ready queue. Fine. Now will that always happen that whatever input output resource this process requires, it is available for this process? No, not necessarily. So in that case, if the input output resource is unavailable or it is occupied by some other process, what will happen is this process will just keep on waiting, right? So there's no benefit of making it wait over here and occupying the main memory. So this portion basically represents your main memory, and this represents your secondary memory. So what happens is the midterm scheduler in that at that point it comes into role, and what it does is it just moves those processes which are waiting for the input output resource which is unavailable right now. It just moves them or swaps them out into the secondary memory, and that process is known as, that state is known as suspended and blocked. So when a particular resource, I'll discuss the definitions of all these states first of all. So let's just discuss the basic idea first. So over here in this state, when a process exists, we say that the process is waiting for an input output resource which is actually occupied by some other process. Fine. So whenever let's say at a point we say that the input output resource is now available. Fine. So at that point the process is shifted to this suspended and wait state. Fine. Now after a process completes or let's say after a process has available that input output resource, the midterm scheduler next makes a call to swap in this process from here to this blocked or waiting state, wherein the process now in this state it completes its input output task and then it is moved to this ready state. Fine. So finally when the process completes entire execution, or let's say there is a scenario when the process is not able to complete its entire execution, maybe it's just executing and its time quanta expires, or some other reason. Let's say I have to forcefully preempt or forcefully make this execution block this process. Now when would that be possible? When I would do so, because in a case when let's say the process is executing but its deadline has already expired, so there is no use of executing that process. In that case I would just forcefully stop that process. So that stage is known as this completed or zombie or dead state. So that's all for the states of this process. We'll quickly discuss their basic definition so that you just get a summarized idea of what we just discussed right now. So I'll just discuss very brief idea of all these states. First of all was the new state. When a process has just been created, it is said to be in this new state. Then is the ready state, when a process has been loaded into the main memory and is awaiting execution on a CPU. Yes, that is known as the ready state. Then running state, when a process is chosen for execution on a CPU, it is said to be in running state. Blocked or waiting state, when a process cannot carry on without an external change in state or event occurring. Example, an input output event, that is when a user input is required or some other event like a command to a printer needs to be served. In that case it is said to be in blocked or waiting state. Then is the terminated or zombie state. A process may enter the state in two possible cases. First, on successful completion of all its tasks. Next, when it is forcefully killed, maybe due to the expiration of a deadline or exhaustion of time quanta. Next are the two extra states which we discussed, which occur or exist in the secondary memory, which is the suspended and blocked, when the input output resource required is not available yet. It is also known as swapped out and blocked state. Next is the suspended and waiting, when the input output resource required becomes free or available. After this, midterm scheduler swaps in such a process to waiting state for completion of such input output task, and this state is known as the swapped out and and waiting state. Please note down that this is very important, that after this the midterm scheduler swaps in such a process to the waiting state for completion of such input-output task and not directly to the ready queue. This is very important. Some of the textbooks or some of the tutors just mention it, or we say that they mention it in a wrong manner, or maybe they mistook this concept. So this has been entirely verified by me. This is also mentioned on Wikipedia if you want to verify. So this is the concept, that it is shifted to the waiting state for completion of its input output task and not directly to the ready queue, because it still has that input output task awaited. Fine. So that's all for for this session of process states and the discussing the various strategies or various schedulers which help in moving the process into various states. So I'm sure you would have got some knowledge about the concept and a better clarity towards the concept. So in case you like this video, please like it and keep subscribed for more good work coming up. Thank you friends.